In the lesson on wind energy resource estimation, we talked about how energy generation from renewable projects is approximated by the bell curve, which is a normal probability distribution curve. We said that the bell curve is used to generate different energy production profiles and that it's also used to calculate the probability of exceedance, or p-value. Many of our students have asked us to further clarify the concept of p-value and how can data about p-values and probabilities be used to sensitize our model. So, in this lesson, we'll clarify the difference between p-values and probabilities and show some of the Excel functions that can be applied to energy generation data to derive generation profiles associated with different p-values that we may need for negotiations or financial analysis. For example, you may want to run a model in a worst-case scenario, which, in your opinion, is annual production that corresponds to a p-value of 99.9%. Engineering reports that deal with resource estimation will not contain all of the p-values you may need. So, how do you derive p-value of 99.9 or any other p-value that you may need? In this lesson, we'll show you how. We'll assume that the average annual energy production is forecasted to be 220 gigawatt hours, which corresponds to the P50 value on the bell curve. We also assume that P90 corresponds to the annual energy production of 160 gigawatt hours. So given these assumptions about energy generation, let's try to find the annual energy generation that corresponds to p-value of 75%. However, before we do that, let's go over the concepts of p-value and probability. When we're talking about the p-value, we're talking about the probability of exceeding a certain energy production level. So P50 would be a 50% probability that annual energy production will exceed the average production of 220 gigawatt hours in any given year. This will be represented by the area under the bell curve to the right of the P50 value. Probability, on the other hand, indicates a likelihood that the annual energy production level will be less than a certain energy production level. Again, if we take the mean value of annual generation, which is 220 gigawatt hours, the probability will be represented to the area to the left of the mean value. So there's a 50% probability that energy production will be less than 220 gigawatt hours in any given year. Remember that our P90 value corresponds to the annual production of 160 gigawatt hours. So the P90 value indicates a 90% probability that the annual production of 160 gigawatt hours will be exceeded, and it's the area to the right under the bell curve. So what's the probability? Probability is the area under the bell curve to the left of the 160 gigawatt hours, and it's 10%. You can see that p-value and probability are related. P-value is equal to 1 less the probability. If we know the p-value, we can figure out the probability and vice versa. The reason why you need to know about probability is that in Excel, we work with probabilities and not p-values. While in independent engineering reports, we get p-values and rarely probabilities. In the bell curve, or normal probability curve, the mean is represented by the Greek letter mu, and the standard deviation is represented by the Greek letter sigma. In a normal distribution, 99.7% of all data falls within 3 standard deviations from the mean. So, if we know the mean and standard deviation of the energy generation distribution related to a renewable energy project, we can practically answer any question related to energy generation. Another concept we have to learn is a z-score. Z-score is a measure of how many standard deviations below or above the mean a data point is. Simply put, a z-score gives you an idea of how far from the mean a data point is. So, 3 standard deviations below the mean correspond to a z-score of -3. Its sign is negative because it's below the mean. 2 standard deviations above the mean correspond to a z-score of 2. To find out the annual energy generation that corresponds to a p-value of 75%, we have to figure out the value of standard deviation in production units, in our case, gigawatt hours. And we can do that by using the difference between P50 and P90 values. The difference between P50 and P90 in terms of energy units is 60 gigawatt hours. And first, we have to find out the z-score that represents this 60 gigawatt hour difference. In other words, we need to find out the number of standard deviations this 60 gigawatt hours difference represents. We'll use the Excel function norm.s.inv to find out the z-score, and the only argument that we need is a probability, which in this case is 10%. So let's go to the Excel worksheet and calculate the z-score. We've got P50 and P90 values, and plugging in 10% probability into norm.s.inv function will give us the z-score of negative 1.282. So a 60 gigawatt hour difference between P90 and P50 value represents the difference of 1.282 standard deviations. To find out the value of one standard deviation in production units, we simply have to divide the difference between P90 and P50 values by the z-score. So the result is 46.9 gigawatt hours. One standard deviation is 46.8 gigawatt hours. Now that we have the standard deviation, we can finally answer the question of what is the annual energy generation that corresponds to a p-value of 75%. We'll use another Excel function to find out the P75 value, and that function is norm.inv. Norm.inv function requires 3 arguments: probability, mean, and standard deviation. Let's go back to Excel and calculate the annual energy production for P75. We know that the p-value is equal to 1 minus probability, so the probability that corresponds to P75 is 25%. The mean value is 220 gigawatt hours, and the standard deviation we've just calculated, and it's 46.8 gigawatt hours. The result is 188.4 gigawatt hours. So the annual energy production that corresponds to the P75 value is 188.4 gigawatt hours. This means that there's a 75% chance that the product's energy production will exceed 188.4 gigawatt hours in any given year. The opposite is the probability, which means that there is a 25% likelihood that annual energy production will be less than 188.4 gigawatt hours in any given year. In this way, we can find out annual energy generation that corresponds to any p-value. We often have to calculate p-values in this way because independent engineering reports and wind studies do not include standard deviation numbers. Often, we may need to find a probability that the renewable energy project will generate less than a certain energy production level. For example, we may ask the question, what is the probability that the project will produce less than 150 gigawatt hours in any given year? To answer that question, we'll have to use Excel function norm.dis. Function requires 3 arguments: gigawatt hours, mean, and standard deviation. So let's go back to Excel and answer the question, what is the probability that the project will produce less than 150 gigawatt hours? So we need gigawatt hours, which is 150, the mean is 220, and the standard deviation is 46.8. The result is 6.74%. So the probability that this renewable energy project will produce less than 150 gigawatt hours is 6.74%. Remember that this probability of 6.74% represents the area under the bell curve to the left.